Testing. All right. Can anyone hear me out there? Give me a wave. Hello. How you doing? Anything? Can anyone can hear me? Who do I see? I see Luna. I got Leos. I got Oliver Stevens. I got Eva in the house. Gayla's here again. Nice to see. I got Car Enthusiast, which I could imagine it might be Artem maybe. I see Aliyah. We're okay. Who else do I got here? I see Jeffrey's good. We got Dougie the Gamer, of course. Lewis, you're here. Welcome. And there's Charlotte. I knew she would join at some point, which is fantastic. That's all right, Oliver. We will do what we can, right? You joined early, or you joined late, pardon me, in the grade. So you tomorrow, I'll see you in the morning. You do your best, right? Thank you. You like my haircut, I know. This is okay, Luna. Enough with the anger. No anger issues on the chat. I'm gonna screenshot this to your parents. All right, so I think I'm almost ready. I'm just plugging in my last things here. And then just give me a second here. It should be okay. So there's my cable. My hair, if you want, I told some of you guys my hair story. I had hair up to my shoulders in high school. They wouldn't let me grow it any longer because I was in a Catholic school. And then from there, one day I cut it so that it had gel and looked really spiffy. And then I realized that that wasn't working. So then I shaved it. And then when that wasn't working, I shaved it even more till it was like bald. And so, no, when I was wrestling, I had long hair. And then one day I got lazy and I didn't cut my hair anymore. So here I am with long hair, beautiful locks, always conditioned and ready to go. So anyways, the hair tutorials cost money. This is free. So, all right. I'm not sure. Jack Manifold. I don't know who Jack Manifold is, Luna. Really, you guys. So, I know that. Thank you, Luna. I know that. Is Emily on here? Emily Brezzi, are you there? If you are, you have to give me a thumbs down if Emily Brezzi is in the house, because you sent me a bunch of questions on École Direct. I don't know if anyone else did this evening. So I could, if not, I'm going to start going and asking people who want. I know Julia, there's M, there you are. Okay. Emily, is it possible, I know this is annoying, but is it possible to send me the questions at this address here straight from your Outlook or something? I'm putting it in champidet.ch because then it's easier. Oliver, you come to my room. Okay, Em, I saw you there. Is it possible you send it, because it's really annoying to look at attachments on École Direct. I can try. All right. I'll see what I can, because you like mail bombed me with questions. 1, 2, 3, 4, 5, 6, 7. You want to know the whole course tonight? No worries. Oliver, my room. Okay. All right. And then Julia, is there a Julia out there? She was talking to me about the quiz. Is Julia out there somewhere? Which email address do you want me to send Jeffrey? I know I was eating. My apologies at a fancy Italian restaurant, but I'm here and I'm going to save your lives. Ah, Emily. Okay, that makes sense. Okay, I didn't look, Emily. I will look at which question it is now. Hold on, I'm opening it up. But I had wonderful carbonara for being late. Hello, doctor. Sophia, no, but I can do some questions for you. So we can do find some questions from the book on what's it called, lines, or I can do a small tutorial for people who don't know how to do lines. That's okay. Emily, I'm going to do yours first since I have it here. So enough with my beautiful photo. All right, now I'm watching the chat, and at the same time I'm doing questions. So if I miss something on the chat, send me an email, my address, and I'll try to look at the question. So if I miss something in the chat, either or if you want me to do something specific, put a star beside the message and I can see it. All right, okay, so okay. M, do you need me to do the question or no? Because I'm not going to do the question if you got it. Okay. And then I think, Jeffrey, I did put my email address on here, but you want me to send it again? There you go. All right, let me just go back on the messages. Just reading some of the message to see if I think so. Jeffrey, can you send the email address? I did for the question. Okay, good. So if you have questions, send me over there. Otherwise, M, you already got it. Okay, so that's fine. Okay, who wants questions? And if there's silliness in the chat, I'm going to take a screenshot and send it to your parents. So remember, this is live and recorded. It doesn't send. Okay, here, watch. I got it now. What you're talking about, Jeffrey. There you go, Jeffrey. Could you do this? And Doggelito, what was your question? I don't know what your question was. Is the first the multiplication does? It does not matter. Is the first the multiplication or does? It does not matter. I don't understand your question. You have to make it more clear. Estelle, if people, okay, Luna, you sent me an email. I got it. For those who don't have the, okay, that's Douglas. Okay. Are you asking me, can you answer my question, please? What was your question, Douglas? Is the first multiplication or doesn't matter? The question that I had up here, Douglas, is that what you're asking? This one. This one here. Just so people know, yeah, I mean, if I were doing this question here, just to show it, I would put the 4 up here to cancel them out here and here. So then you have to multiply this whole side by 4 like that. Then you have x is equal to 4x plus 3. Throw all your x's onto one side, numbers on the other. So minus 3x is equal to 3. Divide by negative 3. Cancel, divide by negative 3. x is equal to -1. So there you go, Douglas, if that's what you're wondering. Let me see what you have here. Luna, I have one by you. So as the emails come in, I will take a look at them. It's small, Luna, but I will make it a little bit bigger, okay? So for those, this is 5t times 25 to the power of t all over 125 t minus 1. So this is indices stuff. Did I get something wrong on the last question? Hold on a second. For the last question, I must have done something wrong. Hold on a second, because Emily's yelling at me now. Did I go too fast? Yes, I see what I did wrong. Let's try this again, Emily. So, put 4 there, cross it out. But then you put a 4 here, so you have 4x plus 12 is equal to x. And then from there you have minus 3x is equal to 12. Then divide by -3 on each side, divide by -3, and x is equal to -4. So sorry about that. You are correct, Emily. It is -4. So good on you. Okay. Yeah, Kayla, I see your question. Calm down. All right, so let's get rid of this one. Let's put back Luna's question. So if you're writing stuff on the chat and asking questions, like I said, it's better if you email me them, because then if I miss it on the chat, then I won't see it, but I'll try and keep an eye on, because it's hard doing 2 things at once. So Luna, for this one, you should change every number of these to powers of 5. So for example, 25, you should change it to 5t, and it's 5 squared, isn't it? To the power of t. And on the bottom, you should have 5 cubed, also to the t minus 1. So that's your first job there. For 11D, Astolfo, no, you should know algebra, lines, Venn diagrams, and all the number sets. Yeah, linear questions and I guess inequalities. You guys should be able to draw inequalities, right? So there's some hints for you there. So just so you continue here, Luna, you have 5t times 5, 2t all over 5, 3t minus 3. These ones, when you time the same base, it's going to be adding the exponents, so you can add these two. So you have 5, 3t all over 5, 3t minus 3. And then finally, what you can do is you can put this up above here with the other guy. And what happens is, so we have 5 positive 3t times everything here switches signs. So you're going to have 5 to the negative 3t minus 3. And if you continue with that, you should have 5 to the 3t times 5 to the negative 3t plus 3. And then when you multiply these, you add the base. So if I add these two, or sorry, when I multiply them and they have the same base, we add these two, but 3t and negative 3t, they cancel out. So you end up getting 5 to the power of 3, which is 125. So there you go for that one. Geometry, we didn't do any line stuff, Emily, like y and x plane this year. So we'll do that next year, okay? So that was that one there, just so you have it. I don't know, Luna, why is it hard? So has someone sent me others? So that was your question there, Luna. I'm gonna check to see if anyone else has sent me any. Jeffrey, you sent me something. That looks fun. So if you guys are confused about linear equations, what you need to do is you have to go to the linear equations section in the book, find a question you want me to do so I can work on it. If you're like, please explain me 3 weeks of linear equation in 10 minutes, it won't work. All right. This one, Jeffrey, geez, you're going to scare the young kids. Let y1 is equal to that, y2 is equal to that. It is given that 1 over this is equal to this. Okay. Find the values p and q, writing your answer in the form p, q. Okay, so you have this. Given that this, so, oh, this is terrible, Jeffrey. Why would you ever pick something like this? Yeah, I know, and this is why I pick and choose which questions you do on Cognitive, because some of the questions are like a waste of time. For example, I think here, this one here, you're supposed to fill in where you see your y1 and y2. So example, if I take this, it'll be 1 minus p times y1, which is e to the x plus e to the minus x divided by 2 minus q times e to the x minus e to the minus x divided by 2, which is equal to e to the x over e to the 2x plus 3. Cognitive gave you this one. Okay. I was going to say you'll never, I don't think you'll ever get a question. This is just kind of a waste of time, but let's see, they both have a 2, so you can technically take a half out, 1 divided by half. He's given that this where it is. Yeah, I think you just have to like simplify this so that it looks something like this. So p e to the x plus p minus e to the minus x all over 2 minus, technically they will have a common denominator, so you can actually write it like this, q e to the x minus e to the let's see, e to the minus x, and then we have that, and that's equal to e to the x all over e to the 2x plus 3. Jeffrey, this is terrible. Why are you doing this stuff? It is given that this were this and this and that. Find the values p, writing your answer in the form p and q. So did I make a mistake already? Because there's so much going on in here. E to the x minus e to the minus x2 minus q. So e to the x plus p e to the minus x minus q e to the x and then we have e to the minus x all over 2. I think, isn't it q times e to the minus x? Q times y2, q e to the x minus, and then this becomes a plus right there. There you go. So we have that. From there, I would imagine you can factor out two things. So p minus q times e to the x. And there's a q here as well, isn't there? There's a q there. Plus q times minus e to the x plus e to the minus x. All over 2. Oh, no, I've done something wrong here. Hold on. Hey, I think you're wasting your time doing this here, Jeffrey, if you want to know. Well, if you want me to continue going, but there's no way the IB is going to give you a question ever this algebraic. This is why Cognity is not so great sometimes. Let's try this again. Plus p plus this goes with this, p plus q times e to the minus x all over 2. That's what I have here. Yeah, Jeffrey, we can continue on, but there's no way they're going to give you anything like this. You should just be able to use exponentials and logs. This is why you should ask me sometimes when you start doing Cognity questions, because if it's taking too much time, it's a waste of time. So I wouldn't worry about it so much. For those in the chat fooling around, I'm just going to start kicking people because it's just a waste of time if I see. So here's my participants. If I see people fooling around, I'm just going to kick them out here. All right, I got a couple more emails, so I'm going to take a look at this here in a moment. Let me just take a look at my emails here. For the persons who are sending me emails, I got about 5 of them here. All right, Jeffrey, Nikita. Nikita's wasting everyone's time once again. Thank you, Nikita, for doing this. It shows that you're growing up a bit. Nikita sends me page 365, 18C, 6J. So there he actually has asked me a question on how to do something. So let me just take a look at what he's talking about. Julia, I got your, could you please do the question from the differentiation quiz? No problem, Julia, I'll get to that, just give me a second. I'm just gonna take a look at Nikita's question. So just Nikita, hold on. I can't see the live chat because I am looking at the book. Here we go. All right, the chat's blowing up here. I stopped looking for a second and all of a sudden. Louis, stop asking stupid questions or I'm gonna kick you out. No one wants to know about Wendy's. Okay, just give me a second here, organize myself. Close this. So for Nikita, you got 18C, so 18C, all right, page 365, 6J, and L. So let's take a look at this one here, J and L. All right. Now I'm worried to look at what everyone's been. So, all right. Okay. Nikita, are you there listening, or you are? All right, because I'm going to show how to do this. For those in grade 11, you should be able to follow these ones. For grade 13, for sure, you should be able to do this as well. So this looks like a quadratic question. So I expand first. Minus x plus 5x minus 1 is equal to 8x. So I've just expanded here. And then from here, add like terms. So you get x squared plus 4x minus 1 is equal to 8x. And then I throw this over here, and you have x squared. You change this negative 8x, so I have negative 8x. Negative 4x minus 1 is equal to 0. And then, let's see, x squared minus x plus 5x minus 1 is equal to 8x. Okay, done this all right. Minus 1, throw that over, negative 4x. And then at this point, you have to use your quadratic formula. So if you have your quadratic formula, you should be able to just do this one: minus b plus or minus square root b squared minus 4ac divided by 2a. Okay. All right, I'll take a second here. Louis, snapshotting this and that's sending it to your parents in like 15 minutes here, because you're just wasting your time. So if you could please leave the chat and leave everyone alone. Nobody wants to hear it. So please leave. And there's the sound of the screenshot I have. So for the rest of this question, if someone wanted to try and do it the box method, it's impossible, because you cannot find two numbers that multiply to get -1 and add up to get -4. So that's why I have to, or I'm forced to use the quadratic formula. So in this case, you have to continue the question putting this as your B, this is your C, and your A is 1 in this case. Okay, so I'll leave it at that for you guys to try. You should know the quadratic formula. If not, you have to look into it. Did I forget the -8? No, I put the -8 over onto this side, Charlotte, and 4x minus 8x is equal to -4x. Oh, all right, no problem. You saw it. Okay. Okay. So this is a quadratic equation question. I would guess Nikita, same thing. You should put this onto this side, this here onto this side, and once again use a quadratic equation. Is it possible that they have a question? I suppose so. You just have to be able to use that equation in order to do this question here. All right. But these ones are probably more complicated ones. The kids who are in my advanced class will probably have to do these next year. So for those who can barely do the 2-star questions, I wouldn't worry about it so much. Focus on just the simple questions, okay? Julia, if you're there. Kayla, you could try and do it, but it doesn't work very much because this is really ugly, because the box method doesn't work on this question here. You want me to do a null factor question? Yeah, I'm going to try and do... Julia, are you there? Because you want me to do some questions from one of the quizzes, right? So grade 13, differentiation quiz. Jeffrey, whatever you sent on the chat, it turned into like mangled garbage. I don't know what you write. So send a screenshot or write me an email. Julie, I see your message. Jeffrey, I'll get to it on Outlook. Send me a message on Outlook if you can, please. Julia, is there a specific one here on the quiz that you want? So can you please write on the chat, question 1 or question 2, question 3, question 4, and I'll try and do one for you. Matthew, I don't. Yeah, Julia, just tell me which question you'd like, and I'll grab one and I'll do an example. And Jeffrey, I saw your request for an exam type question on normals and tangents, so I will find one for you, okay? Question 2 and 3, all right, I'll do question 2 and 3, and then Jeffrey, I'll do one for you. And then I think, Kayla, you said something about null factor, so I'll try and get to that as well, okay? So just give me a second. So question 2 and 3. So question 2, you want me to do all of question 2 and all of question 3? Question 3A, question 2 and question 3A, okay, all right. So for this question here, you want to derive, it's best, Julia, and any other 13s, is that you imagine this thing as a block. So if you ever derive E, you get E to the block. And then after that, you have to times that by the derivative of him. So if you derive him, you get minus 4x. So there you go. Okay. So that's what we have there, Julia. That's all you have to do for that one. And in this one, I told you guys it's best if you rewrite this as cos 4x cubed, and now we derive it. So if I derive this, you should bring the 3 out in front. Pretend this is a block again, so we don't touch the block inside the brackets. So cos 4x, and now we minus 1 off here so that it's to the power of 2. And now we have to chain that onto the derivative of this, and the derivative of cos 4x is minus sine 4x times by, once again, the chain rule, which is 4. So there you go. So that's question number 2. Give me a thumbs up, Julia, if you understand that, and I'll get the other 2 out for you, okay? All right, so there's that first one, and then if we do the next one, Julia, I believe it's this one here that you were looking for. So this is product rule, because you have this piece multiplied against this piece. Wait, why would you the chain rule in B? Because remember, if we have something like, imagine I have 2x plus 5 to the power of something. If this power is not equal to 0 or 1, we have to treat it as if it's like x cubed, like something like this. And if I derive x cubed, you put the 3 out in front and you subtract 1 off there, right? So think of this block inside here as your x. So I bring this number out in front, subtract 1 off of here, but when we have something other than x cubed, like inside here, like some other polynomial, some other function, we have to multiply by that chain rule here. All right. Louis, I'll check my emails. I just got it. All right, Julia. So I can send you to the book and show you all the practice of the chain rules that you have to do in there. But normally they're anything like square root of something. That's a chain rule, because if I rewrite it, it's to the power of 1/2. So that's a chain rule already. All right. Notice if this is not 0 or 1, and you have some polynomial or some cosine or some what I would call like a mini function inside here, then you have to use the chain rule. So for example, in this one here, we know that we have to use the product rule. Okay, so we have two pieces of this, and the product rule says derivative of the first times the second plus the derivative of the second, derivative of the second times the first. So the derivative of x cubed is 3x squared times by just normal g. So I'll call this guy f and I'll call this guy g. Okay. Then we have 5 minus x squared. So that's the first piece from here, plus the derivative of this thing. So if you don't mind, I'm going to rewrite this on the side as 5 minus x squared to the power of 1/2. So if we derive that, this 1/2 comes out in front. I subtract 1 off there, so it's minus 1/2. We keep everything inside this brackets the same, but we also have to chain that on here. Okay, so the derivative of 5 minus x squared, well, this goes away to 0, and this becomes minus 2x. All right, so that's just the derivative of him, but we also have to times it by f, which is x cubed. So finally, I have to times it by x cubed. Okay, and that's really ugly mess, but you can probably clean it up a bit. For example, this -2 times this 1/2 would just give you -1. This x times this x cubed will give you x to the 4. Then this here you can rewrite, if you want, underneath here as square root 5 minus x squared. But once again, in the book, they might clean it up a little bit. And here you could just keep this as this here. All right, Julia. So that's what you have to do with that question there. Okay. Louis, I sent you an email. You sent me an email. You want me to do? I'll do one from Louis, and then Jeffrey, I'll come back to do you and find one on tangent and normal. So, Louis, you want me to do a single question on radicals? Louis, you guys, it's best if you could at least tell me where on which pages you want me to look at, right? Otherwise, I'm just like searching through the book. If you just say, go to page 275, I can go straight to 275. Okay. Julia, I'll leave some of the other questions for you. If you want me to do more, I'll leave the file open and then take a look. And then for radicals, radicals here. So yeah, Louis, you have to kind of give me an idea on what you want me to look at. Page 85. Oh, that's how. Yeah, I'm on page 85. So here you go, Louis. We're on page 85. Pick a question. What do you want me to look at? And the Astolfo, whoever this is, thanks for not using your name, so I don't know how to answer to who it is. I'll look at the question again. Just write down in the chat, please, what page and which question. Any of them. Okay, well, I mean, you have to know the general rule of, so I'll grab a few of them. That's Matthew. Okay, thank you. Please, you guys, please know how to multiply square roots. All right, Louis. I mean, one as simple as this, for example, this D, you just FOIL it in and it's 6 times square root 11, which you can't simplify. And then 6 times minus 4 is minus 24. That's it. Okay. And then if you want to do a harder one, Louis, let's grab, let's say 2b. All right. And then you have negative 2 times negative square root times 3. Well, there's a hidden 1 out front. So negative 1 times 3 is negative 3 square root 2. And then square root 2 times square root 2 should just give you 2. And minus times a minus shall give you a plus. So there you go. You have this one. All right. So that's one second question from there. So all these here are you just foiling in and knowing how to do your square root rules. It's good that you guys are putting pages on the chat, but you gotta please email it to me, because once the chat moves up, I can't see them anymore. So I don't mind you guys throwing pages down, but you gotta send an email and just say, even in the subject line, just say page 85, number 5i. Okay. And then if you want something more complicated, you guys, for surds, something as straightforward as this, it's just a more foiling. So that times that is 9, that times that you add, because it's positive 3 square root 2. Square root 2 times 3 is another 3 square root 2. And then square root 2 times square root 2, well, that is just 2. So you need to know your surd rules. Now I add like terms. 9 plus 2 is 11, and then 3 square root 2 plus 3 square root 2 is 6 square root 2. And then you have your thing. And Louis has to go in the middle of the question. Fantastic. Anyone else has questions? Luna, okay, Luna. All right, for the 11s, just hold on a second. I'm going to do one question with Jeffrey here. So just give me a second, Jeffrey. I'll try and find something. If we go into the book, I mean, the book has IB questions as well, Jeffrey, not just, let's see. The graphs of linear equations, yeah, you have to hold on. So let's see, calculus, tangents and normals, right? That's what you wanted. Tangents and normals, update. I'm just trying to find you a good question. We already did that question. That was quite difficult for you. Let me just find something here more based in the book, because it'll be easier to find. So if we go to calculus, properties of curve, introduce this, tangents and normals. So let me try exercise 13b. Is there a specific one here that you can see that you want to try? Jeffrey, can you take a look in the book and see if there's one there that you can see that was helpful. Otherwise, I would keep looking for another type of IB question here. Hold on a second. Yeah, I see, Nikita. Give me a second. Just give me a second, trying to find something. Jeffrey, are you still there? Can we try one of these questions, Jeffrey? Take a look at them and see if any of these ones are somewhat might be helpful. Tell me which one you would like to do. This is just finding the equation of the normal, right? Otherwise, I could go to the review set and find something in the review set as well. C and D, please. Okay, I'll do C and D. So find the equation of the normal. All right. Grade 11s, hold on. I'll look at your questions in a moment. I'm just going to help my grade 13s here. So let's look at these two here. So I gave you my poster so you kind of know what to do. So they want to find the equation of the normal. So you need to do the flip and switch in the middle, right? So first, derive e to the 2x minus 1. So the derivative of that is derivative of this guy here is himself e to the 2x minus 1 times by the derivative of 2x minus 1, which is 2. So there, this is your gradient function. M is equal to e to the 2x minus 1 with a 2 in front. Next, it asks you to have it at x is equal to 1, so I put 1 inside my x here. So I have 2 times 1 minus 1, so you get 2e to the 1. So that's your gradient of the tangent line. Now we got to do the flip and switch. So the gradient of the normal is negative 1 over 2 sorry, had to sneeze. Negative 1 over 2 to the e to the 1. Now you start developing your equation. Y is equal to mx plus b, which all the grade 11 should know. Which is y is equal to negative 1 over 2ex plus b. Now you have to insert an x and y value to find your b. So in order to find your y value, you should put this back into here and find your y. So if that's the case, you have y is equal to e to the 2 times 1 minus 1, which is equal to e to the 1. So your y is e to the 1, negative 1 over 2e, and x is equal to 1, so that doesn't do anything, plus b. Now I throw them over there, and you end up getting b is equal to e to the 1 plus 1 over 2 e to the 1 as well. And now your final stage is writing out your equation. So y is equal to negative 1, 2 e to the x x plus b, and my b is this awful thing, which is e to the 1 plus 1, 2, e to the 1. Yeah, that's what I did, Jeffrey. I put this here, this x is equal to 1 here. So it's e 2 times 1 minus 1. That's my y, which is e to the 1. There you go. And then for the review set, Jeffrey, you want me to send a copy of it? Is that what you're asking me? I don't understand, or you want to know what page it's on. The review set is on page, it's this one here, 13A on page 340. Jeffrey, I'll do the second one as well. So the second one is this here. I'm sure the grade 11s are watching this and going, oh my goodness, this is what Charlotte and Ollie and Luna are going to be doing one day. I hope you're excited. Okay, derive sine x. Well, that's easy. F prime is equal to cos x. Right? So that's your gradient, m. But we want to do the flip and switch. So negative 1 over cos x. So that's my gradient of the tangent line. And then from there, they want to find it at x is equal to pi over 3. So I can put that in here. So negative 1 of cos of pi over 3. And if we do the unit circle, oh boy, I can't wait to teach Charlotte the unit circle. Pi over 3 is how 180 divided by 360. So that's that. Cos of 160, of 60 degrees is a 1/2. So negative 1 divided by 1/2. Well, that's equal to negative 2. All right. From there, let's create this equation, minus 2x plus b. Now we want to find the b, so we have to insert this into the original form. And if you do that, sine of pi over 3, well, we already know that that's square root 3 over 2. So that means we have square root 3 over 2 is equal to negative 2 times my x, which is pi over 3, plus b. Once I throw this over here, it's quite ugly. Square root 3 all over 2 plus 2 pi over 3. That's your b. And now our final step is to rewrite the equation of the tangent, which is y is equal to mx plus b. So negative 2x plus my b, which is this terrible thing, square root 3 divided by 2 plus 2 pi over 3. So there you go. All right, so those are two questions where you have to find the normal. All right, Nikita, what you want me to do? Let me go to my email. I'm just getting mail bombed again here. Luna, page 85, 5I. Let's see. Page 85. Is this the one that... Oh, no. This is not Nikita's. Nikita can wait for a second. Page 85, number 5I. 5I. JKI. So, Luna, is it this one here? Is that what you're asking me? Just to make sure we're okay. All right, Nikita, don't worry, I'll get it done in a second. Tell boarding that I'm online. Mr. Higgins writes me an email. All right, I'll do yours in a second. I'll do this one, then I'm doing yours. So that times that is 4 times 2. That times that is minus 2 square root 2. That times that is positive 2 square root 2. And finally, 1 times minus 1 is minus 1. And that's nice because these two eliminate. And you get 2 times 4 is 8 minus 1, which is 7. So very nice. All right, so Luna, that's your question. And then for Nikita, page 81, 6H. Page 81. (6H). Is this the one that you want to do, Nikita? Can you say yes, Nikita, if this is the one you want me to do? Yes, okay, good. So these ones, if ever you have a mixed fraction, the first thing you should do is change this to an improper fraction. So 9 times 7 is 63, plus 1 is 64 all over 9. That's your first step. And then after that, you can split the square root up because that's a square root rule, like so. You're allowed to do that, to split into 2 different houses. And then from there, it's quite simple. What's the square root of 64? Well, it's 8. What's the square root of 9? Well, it's 3. And then you're done. That's it. That one's all you have to do for that one. All right. Next. You have to change. You guys have to know. I'm sorry. In grade 11, you guys have to know how to change mixed numbers to improper fractions. You times it going this way, and then you add it going this way. So 9 times 7, 63, plus 1 is 64, all over 9. And you guys, grade 10 fractions. That's all you have to do, Charlotte. Add the thingy after you multiply the denominator. And then apply your surd rules. All right, so there's that question. And there's something else in my email here. So Luna, I did yours. Nikito, I did yours. Louis, radicals, I did. He runs. Jeffrey, you did yours. Luna, I did this. You have another one, Luna, here. This one here, I just saw yours, Luna. All right. So, this one, Luna, you should have this 10 to the 5 and 10 to the 4 the same, because it's kind of like saying the same, if you have the same base, right? Like 10 to the 2 times 10 to the 3, you can add the exponents. So actually, no, you can add these right away. So 10 to the 5 times 10 to the 4 is 10 to the 9. That's easy. And what's 2.81 times 3.4? That's all you need to do. So you just need a calculator for this one. What's 2.81? Wow, just get your calculator. Let's see if I can find my calculator. So 2.81 times 3.4, you get, this is just 9.554 times 10 to the power of 9. That's all you have to do. Yeah, there you go. Thank you, Charlotte. That one's piece of cake. I mean, your calculator, even if you guys are allowed calculators, so I think your calculator would do all of this. For a third question, let's see. I mean, sometimes you guys aren't so great at simplifying. Harder questions would be something like, that should be straightforward, that should be straightforward. I'm not quite sure if we did rationalizing the denominator. I might have skipped that because you guys would have had trouble with this. To be honest, I think this one would be a hard one for you guys, but I think I only had one hard one in one of the first tests. But a third question, you just have to know your third rules and apply third rules. So just make sure you guys know if you want to do a 3-star question on my test on third rules, you gotta know the concepts and know your third rules, right? Multiplying thirds and dividing thirds. So make sure if you understand those, then you should be okay for the 2-star and 3-star question. Ollie, because I know you're. And the extended box method, I don't know if I did any extended box method. I would like to do more with you guys next year because quadratic equations already destroyed you. Wait till we do quadratic functions next year. Then you're in trouble. A divided third? Yeah, sure. I mean, try, let's see, a divided third. I mean, there's stuff like, things that I think that you're going to have to do next year for sure is, we did do some of this, like for these ones here, right? So take a look at this one here, Ollie, and ask me which one you would like to do. I'll leave it up here. Kayla, worry about the easy stuff. Don't worry about the hard stuff. You're gonna have a heart attack before you even get into the room tomorrow. M, please. Okay, we can do M. All right, I see. So this one here, I mean, you have to read the instructions, right? Write with an integer denominator, meaning this number here on the bottom, they want that to be they want it to be an integer, not a third, okay? So this was the trick. We learned this a long time ago. In order to get rid of a third in the bottom, what you do is multiply this thing here by the same thing on the top and the bottom, like so. And then now what happens is square root 5 times square root 5 is 5. And negative 3 times square root 5 is just negative 3 square root 5. That's all these questions are getting you to do. Is just getting you to rationalize the denominator, meaning make the denominator a non-radical. All right, make it like an integer from a positive or negative number. So that's how you do these ones. We did have harder ones as well, which are these ones here. These ones probably would have like destroyed half the class. This is the flip here, Ollie. So for example, this is if you want to rationalize the denominator when instead of just having like one radical, you have a radical plus an integer, like so. Okay. Yes, please stop with the useless messages. Nikita, Louis, anyone who's just writing useless stuff, just go to bed. All right. So Ollie, this is this one where you write the exact same thing, right? But you switch the sign. And then you do that to the exact same thing on the top and switch the sign. So that's what you were probably asking about, was it not? Let me know if that's what you were talking about. All right, sorry, I'm back. I let you think about it for a moment. All right, here, watch. That times that is 7. That times that is negative 2 square root 7. 2 times square root 7 is the exact same thing, but the opposite sign. So there you go. These cancel. And finally, 2 times negative 2 is negative 4. So you get 3 on the bottom in the end. All right, so that explains that. Jeffrey, you can use one of my calculators for tomorrow. And I see your question as well. Please, grade 11s on the chat, bring a ruler and tell your friends bring a ruler. Someone go on your grade 11 WhatsApp chat or whatever and tell everyone to bring a ruler, a straight edge. All right. In the top, well, it's just going to be square root 3 times square root 7 is, well, you can bring them underneath the same house. So it's going to be square root 21. And then square root 3 times negative 2 is just negative 2 times square root 3. And you're allowed surds in the numerator, just not the denominator. Remember that. That's a very nice invitation to your group chat, but in the school, I'm not supposed to be chatting with anybody or having any group chat. So when you graduate, we'll group chat for the next 50 years. Jeffrey, I'll do this question that you asked. So all these questions are the exact same thing. You just multiplied by the same thing in the denominator, but you switch the sign and you put it in the numerator as well. These ones are very repetitive and boring. So you should be able to do all these ones here. If you want, try one and come back to me and I'll try another one, okay? For Jeffrey, because I think you're here. Consider the function f of x 2x, find and classify all stationary points, okay? So if you want to find stationary points, that's where you have maxes and mins, right? So this is a stationary point, stationary point, stationary point. And at stationary points, your derivative is always equal to 0. So you must derive this thing and set it equal to 0. So if we derive this, you get 6x squared minus 6x minus 36 equal to 0. And even the grade 11s should be able to solve this one. So grade 11s, if you want to practice your quadratics, try and solve this one. 6x squared minus 6x minus 36 is equal to 0. So Jeffrey, solve this. Tell me, and please don't tell me you're going to use the quadratic equation. Sure, Louis, I can do Venn diagrams. Find the page for me and send an email so I don't forget. Jeffrey, how do I solve this? You better know how to solve this. Although you have your calculator, so you can do it without the calculator. Luna, what do I do? Tell me. All right, now you can divide out the 6 because it's an equation. You can factorize it out, but it's better to divide it out. And then good old box method. Then box method, two numbers that multiply to get -6 but add up to get -1. Lou, Kayla, you should be able to do this. Come on, get your calculator out. And this is the null factor you were asking for, Kayla, actually. This is the null factor rule, remember? I factor, and then I equate these separately equal to 0, and I solve. So I get my answers as x is equal to 3 and x is equal to -2. There you go. So for you, Jeffrey, if it says find and classify all stationary points, well, we know that one's at x is equal to 3 and x is equal to -2. And now we have to classify them. Technically, if you have a calculator, you can just do that, right? You don't have to, because you can graph this thing and look. But what you should do, if you don't have a calculator and it's a paper 1 question, is you have to do this sine diagram. So it's like this. You go like this, 3, and at 3 you have a gradient of 0, and then you insert a value on the left of 3 and insert the value of the right of 3. So remember our derivative was 6x squared minus 6x minus 36. If I put 2 into this, you get 6 times 4, 24, minus 6 times 2 is 12, minus 36. You get a negative number here. Next, if you put in 1 inside here, you get 1 minus 6 times 1 minus 36. All right. And you also get a negative number. So there's something weird here. is it? What kind of? This might be a bizarre graph. Maybe it's this graph that looks kind of like so, right? So we can graph and see what it looks like. But did I? 3, I put 2 in there. 4, 6, negative 12, negative 36, 6 to 4, 24, plus negative 6 times 2. Wait a second. 24 minus 12. Yeah, that's negative. And 1 that's also negative. So maybe it's like this. I'll graph it just in case it's something bizarre, Jeffrey. Because the signs don't change. If the signs don't change, it's not a max or a min. So 2x to the power of 3 minus 3x to the power of 2 minus 36x plus 7. How ugly does this thing look? Nope, it's not bad. Ah, I'm putting the wrong, oh no, that's right, put 3 in. You don't have a calculator. Ah, Jeffrey, you should have came and got one from today. No, there's something else that's wrong here. So 6x squared minus, so second function, because it doesn't look, but Jeffrey, you can use, Jeffrey, go on to, what's that graphing site that we use for graphing software? Desmos. Go on to Desmos. Nope, it's this. So in second function calc, max. It does happen to have a max at -2. That's correct. So y is my sine diagram, and then at x is equal to 3, it does. So if I put 2 in there, I put 2 into my derivative. 6x squared minus 6x minus 36. If I put 2 in there, 4, that's 24 minus 12. I'll take a look at it in a second, Ollie. I see your question. It's negative, then 0, then positive. So if I put in around x is equal to 3, if I put 2 in there, six x squared, 2 times 2 is 4 times 6 is 20. Minus 6 times 2, which is 12 minus 36. So that's negative for sure. And then if I put, why did I put 1 in there, Jeffrey? 4. What comes after 3? 4. I'm stupid. All right, that makes sense. So 6 times 4 squared minus 6 times 4 minus 36. Well, that's positive. That'll give us a positive sign. So going from a negative gradient to a positive gradient, well, that's a minimum. So we know that at this thing here, we have a minimum. That's why. Sorry about that, Jeffrey. Way too easy, but I'm just like not thinking. All right. And then you should be able to do that with the other question as well, with x is equal to -2. But your sine diagram should be something like this. So if this is -2, it's at 0. If this is -3, we should have a positive number, and we have -1, we should have a negative number. Okay. So -3 in here, that becomes positive. 9 times 6, yeah, this will be for sure positive. That's correct. I put -1 in here. -1, -1. Yeah, then you get a negative. So this one here goes from a positive gradient to a negative. So this is a max here. Describe the behavior of the function as x goes to infinity and as x goes to -infinity. Well, as x goes to infinity, y goes to infinity. So if you put x into infinity into here, you're going to get, yeah, something, this is a curve that's going to be like this. So as you put minus infinity into x, you're going to go way down. If you put positive infinity into x, you're going to go way up. So that's all they have to do. They're all asking you that. It's not a sine diagram. It's a cubic. So look, if all cubics look like this, if I draw an xy plane like so, it should look, a cubit does this. All right. And then it says sketch the graph of y equals x showing the features you have found. So to sketch this, we found that x is equal to 3 is a min. So that right there, that could be 3. X is equal to minus 2 is a max. It goes through the y-axis at 7. So this is 7. And after that, you could find the zeros of this, but it's kind of difficult. But that's all. This is a rough sketch of it. Okay, Jeffrey. Does anybody actually have more math questions? Because if not, I'm going to leave. All right, going back to the chat. Anyone talking about anything? Okay, let's see. Okay, Jeffrey, got it. Yes, thank you. Good. Ollie, I do. Yes. Yes, something difficult for year 11. Ollie, send it. Indices 2-star. Olivia, stop the spam, please. I'm just here because it's fun. Okay, Kayla, go to bed. Yes, please. I don't know what's happening. Kayla, go to bed again. Are you guys done studying? If so, I'm gonna go to bed. Yeah, if it's just, you guys ruined it. Someone's gonna rickroll me. You're gonna hear the music in the background and I'm gonna fall on the floor. Exercise 11E. G. GKL. Maria, I just got your email too. So anybody who needs to review linear equations, I'll do that in a moment. It's a good idea. Nikita, which one did you want me to do? Isn't Matthias supposed to be laying in bed, like not moving? Nikita, which one do you want me to do? G number 11E1. All right, Nikita, tell me here if there's... Nikita, please on the line, tell me if these are the ones that you want me to do here. Oh, by the way, Luna wanted me to do some sort of dance if someone gets a 7 in the exam, so I had to put like 8 more 3-star questions so I didn't have to dance for everybody in the class. I think you guys need some SOS on your math skills. The chat just blows up. Fantastic. All right. Don't worry. I took grade 14 3-star questions for Matthias. All right. This one, you guys should be able to do this. This one for the guys. Yeah, Maria, I saw your question, so I will. I'll do them in a moment. So, you guys, sure. This is just finding common denominator. Nikita. So, what's the common denominator between 6 and 8? 48. So he needs an 8. So you put an 8 up top here. He needs a 6. So you put a 6 up top there. And you get 8 times 5a is 40a. 6 times a is 6a, so minus 6a. And now your common denominator is 48. That's all you have to do for this one. All right, and then 48 minus 6a is 34a over 48, and then you can reduce this by dividing out by 2, everyone, so 17a over 24. So there you go. That's how you do this one, Nikita. So Nikita, I did your first one. You guys don't swear in my class. I'll kick you out now. Nikita, write back and tell me if you want me to do any more or if you understand the rest of them. The rest of them, it's the same thing. Here, you need to make this 4, and you put the 4 up there. You put a 3 there and a 3 there, and now you have your common denominator over 12. Here, you need just times it by 4 and times it by 4, and now your common denominator for this one is 8. That's it. 24, you're right. Charlotte, if you would have chose 24, then you wouldn't have to reduce in the end. So if we would have found the lowest common multiple between 6 and 8 is 24, yeah, that works as well. Line stuff. All right, good question. Let's look at this one. You guys remember this? So Maria, you sent me this question. So let's do some line stuff together. All right. I would advise it's a good idea to know lines. So let's review them quickly. Hint, hint. All right. Ollie, that's fine. We'll do dividing algebraic fractions. So for you, Maria, the easiest way to draw lines is making a table of values. So you make your x here and y here. Now, these two of them, both of these are in gradient intercept form. Gradient intercept form. And as soon as something is in gradient intercept form, then you should know that it's in y is equal to mx plus b. Okay, so look, in this question, the m is equal to -1 and the b is equal to 4. All right, and now we have this question here. You should identify the m as well. You guys should be able to identify gradients. The gradient in this question is 2/5. So that's equal to 2/5. And your y-intercept in this case is the b is equal to 1. So the easiest way to start graphing these types of questions is figure out what your y-intercept is and plot the dot right there. So I plot one right at 4. That's where it crosses the y-intercept. For this question, we know that the y-intercept is at 1, so I put a dot at 1. And now the easiest thing to do is find another point here to put on, and then you can connect them. For example, if you make x is equal to, let's say 3, you should pick something along the lines here somewhere on your graph, your chart. So if you put x is equal to 3 into this equation, you get -3 plus 4, which is 1. So you have a coordinate at 3, 1. That's 1, 2, 3, 1. There it is. So that's my point. And now I just take a straight line. Or let's see if I can do the straight line. Whew. Nope, not good enough. That's pretty good there. There's my straight line. And now don't forget, you guys, to put your little arrow guys. Like so. Tack, tack. So that's for this one here. This is for A. So this line is A. Okay. And then line B, let's take a look at the second one. Well, we already have one point, right? We have the point here. And so I'm going to do a table of values for my second point. So I have y is equal to 2/5 times an x, which I don't know, plus 1. So which x should I pick here? Well, I'm going to pick 5. And the reason why I pick 5 is because if you put 5 here, these cancel. And you end up getting something nice without fractions, which is 2 plus 1, which is 3. So my next point I have is 5, 3. And now where is that? 5 is over here. And 3 is up here, right there. Ta-da. So I got my 2 points. Once you have 2 points, you just come along here, grab your line guy, and draw your line like so. And put, as Charlotte would say, the little thingies. Charlotte, the thing is, in order to draw a line in space, you need 2 coordinates. So I already found this y-intercept because that's super easy, and I found this y-intercept because that's super easy. So now I just have to find another x-coordinate. So you should try and pick an x number between, I would imagine, 10 and -10, and see what your y value is. So me, I just picked one, 3 or 4 away from this value here. So I picked 3. You could have chosen -3 and you would have got the point up here. All right. Or on this question here, if you wanted to, I could have chose just like -1. But if you would have went 2/5 times -1 plus 1, you would have got this really ugly fraction. And I know how much you guys love multiplying and adding fractions, so I purposely chose a whole number that matched the denominator so I could eliminate them. Yeah, Ollie, I see you. You want indice laws. Ollie, go to the trimestral exam and find like really crazy indice laws for me. One thing. Otherwise, I'll give you one in a moment. Okay. Let's do another one, Charlotte, if you want. Okay. Like these ones were the harder ones. All right, here. No, I'll do one straight from scratch. Okay. Let's do this because it's easier if I start from scratch. So if I go like that, I have my, there's my y-axis, here's my x-axis, and I want you to graph, I'll pick a line for you to graph. Please graph, I don't know, y is equal to 2x minus 1. Please graph that, all right? So the first thing you guys should realize is this is in y is equal to mx plus b form. So that's in the gradient. That means this b is this guy here. So he crosses at -1. So let's put -1. I know I don't have any numbers on there, but it's just a sketch. So we put -1 there. Okay. Now we want to find another point, right? So this line that I've just created here obeys the laws that if you put a value of x in here, you will get the associated y here. So if I do this thing called a table of values like so, that means I could use something like 1,000 if I want to, and I could insert it into my x here and figure out what is my y. But on this axis, do I have x is equal to 1,000 way over here? Normally on a test, you won't have something like that. Okay, because I'm not going to give you an x-axis with 0 to 1,000. That's crazy, Charlotte. You're going to have to draw an x-axis across the room against the wall. So normally it goes from -10 to about 10 at the most. Okay, and then from there I'm like, okay, well, if I have these numbers, let me pick an x somewhere within the vicinity of -10 to 10. So let's just pick, instead of something stupid, let's pick 3. Okay, then I take my formula, which is 2 times my x, which we've chosen as 3 because it's somewhere sensible on my axes between -10 and 10. And I subtract 1 because that's what the formula says. And that's going to equal to his y guy in this xy coordinate, because each x guy has a y guy as well. So if we do that, we put 3, 2 times 3 is 6, minus 1 is 5. No problem, Maria, I saw you. So 3, 5. So where's 3, 5? You're going to say, well, there's no numbers on my graph. Yeah, you guys, Charlotte and company who are going to sketch, you're going to have to learn how to sketch. And sketch doesn't mean you have to have lots of numbers. It just means it has to be semi-accurate. So where is the point 3, 5? Well, 3 could be somewhere around here maybe, and 5 could be somewhere like, I don't know, ooh, shoot, -1. That's down here. Sorry, I'm stupid. So I wrote y -1 is my y-intercept, but for some reason I added this +1. So let's change that. So -1 is down here. Let's go back to this. 2 times 3 is 6, minus 1 is 5. 3, 5, so where's 5? 5 is about there. Ta-da, there's that. And now I draw my line, which is right about there. Check, check. All right, so there you go. Charlotte, you can choose any random number you want, but if you get a value of y and you don't have, like, say you get y is equal to 400, and this thing only goes up to 10 while you've chosen a number of x, which doesn't work. So you should try a smaller number. All right. So now that's if you have when you have the equation in gradient intercept form. Now look at these ones here. For example, I'll grab this one here. If Maria, if you're still listening, this is the other kind you're supposed to have. Okay. So this is when you have this other form that we talked about called the general form. I think this is what Douglas was talking to me about the other day. AX plus BY is equal to C, which is on your formula booklet. I put that on the front of it, so if you can recognize the look of it. And I taught you guys the advantage of this format is you can have an XY table, and all you need to do is make one 0 the X and make the other 0 or the Y 0 and solve for them separately. And then what they do is they give you the X and Y intercepts. So we did this a while ago. So for example, let's take this equation here. 2x minus 3y is equal to 6. And imagine we put x is equal to 0 in it, so this one. So 2 times 0 minus 3 times y is equal to 6. Well, this goes away and you have negative 3 times y is equal to 6. That means my y has to be equal to 2. So now I have a coordinate at 0, 2. That's the first thing I did. So if you want to plot that, where's 0, 2? Well, the x is 0 on the y-axis and 2, so that's ta-da right there. All right. Now let's make y 0. All right. So in this form here, Charlotte, when you do the general form, this is the general form here, you use this technique which I'm showing you, which is to make x 0 and then y 0, and then you just plot those 2 points and join the line. So let me finish. I'll go 2x minus 3 times 0 is equal to 6. Okay. This goes to 0. Divide by 2, divide by 2. X is equal to 3. So that means that I have 3. So my other point is 3, 0, which is right here. And now all I need to do is draw my magnificent line, which is like this here. Ta-da! Done. There we go. Your question here. There you go. So, Charlotte, this is what you're asking. And then box method, Emily, here I'll make a question up for you so you can figure that out quickly. X squared plus, let's see, 5x plus 6. Let's factor this. So we make two numbers. Super laggy. Two numbers that multiply and two numbers that add up together. So the two numbers that multiply always have to be this guy here, the lone number here, 6. And the two numbers that add up together have to be this middle guy here that has the 5. So what are these two numbers? They should be quite easy. 2 times 3 gives 6. 2 plus 3 gives 5. So ta-da, that works. So once you have these numbers, you put an x here and x here in your brackets. You put this number here if it's positive. You put this number here where that's positive. Yeah, I put the microphone on mute for a second while I was writing the stuff. So, Emily, that's how you do the box method. And there's a bunch of questions in the book. I can tell you what page. If you want to practice them, let me know and I'll tell you what page they are in the book. No, you guys, I put it on mute. That's why. I was tired of listening to myself. Simultaneous, yeah, I mean, simultaneous equations. Ollie, oh, sorry, Ollie, you were asking for, surd stuff. Okay, hold on. No, indices stuff. I heard you. All right, Ollie, I'm trying to find some. All right, Ollie, you're hating, so it's all right. I understand. I missed it. Douglas, are you asking about something? Sir, can you give us that one line thing that tricked almost all the class in that test? Oh, you mean the vertical graphing a vertical line and a horizontal line? Douglas, is that what you're asking? Or are you asking this one here, Douglas? This thing. Yeah, this one here, I mean, this was supposed to be an easy question for you guys, but for some reason nobody paid attention to the y-intercepts and stuff like this. So take a look at it again and figure out. I'm just trying to see if I have any more very difficult indice questions. Yeah, if you have to find the x-intercept, the x-intercept is always when the y is 0. If you have to find the y-intercept, that's always when the x is 0. So you just put x and y as zeros into these things and you find them. And you guys, that's like 101. Like math 101. Algebraic fractions multiplying. Here's something. Ollie, maybe you did these ones here. Here, Ollie, like this. Tell me if this is something you want to do here. Ollie, tell me if you know these ones here. Or is that okay? I'm just trying to find a crazy indice problem for Ollie. So hold on, because I'm missing the chat. Let's see if I can find a really crazy one for you. Oh, here you go. You're gonna love this, Ollie, if you're still on. Yes, I do not Slayer. And then I have this one here, Ollie. Do this one here. Everyone try this question here. Simplify, please. I'm gonna get a drink of water. I have 8 of these. They're all 3-star questions. Good luck. I'm muting the microphone so you can go crazy. I'll be right back. All right, I'm back. What's going on? Zoom, please. All right, file, view, zoom in. So which one do you want to try? These ones all look fun. Please, I want you guys to calm down. I'm gonna like bail on this pretty soon. Here's another screenshot so that I can send it to some parents. Ready? Good. Thank you guys for being stupid on the chat. All right, so you want to do the green one. All right, good. For those doing grade 12 HL, you better be able to do these green ones like super easy. So I told you guys there's this thing where if you have this square root of something, you could rewrite it as x to the power of 1/2. We did this a long time ago with fractional indices. And then I told you that if you have something like this with a 3 in front, then you have to write it as x to the 1 over whatever this number is, 3. So you have to write that. So now you have the square root with a 7 in front. So I can write this whole thing to the power of 1 over 7. So a to the 21, whoops, 3 to the power of 14, and b to the power of 7. And then on the bottom, I can write this whole thing as well to the power of 1 over 3, which is 125, a to the 6, b to the 6, like so. And then once you know that, if you remember those rules with the radicals changing into fractional indices, then it becomes just a joke. So now you take this and multiply it into every one of these, like so. So 21 times 1 over 7 is 3, so you have a cubed. 14 times 1 over 7 is 2, so you have 3 squared. And then you have b to the 7, so 1 over 7 times 7 is 1, so you have b to the 1 all over. Now 125, you should write this as, if you're smart, 3 cubed. So you're going to have 1 over 3 times 3 from him, so you're going to get 5 to the power of 1. 1/3 times 6 is 2, so you have a squared. And 1/3 times another 6 is b squared. And now you can simplify it a little bit more. So a squared, I take 2 out of here, so I have 1 left. I'll use a different color. So I take that out, and I have 1a left here. Take 1b, take 1, so I have 1 left there. So I'll redraw this. I have 1a at top, 1b on the bottom. I have the 5 on the bottom, and I have 3 squared, which is 9. If your calculator does 125 to the 1/3, Charlotte, you can do that, I guess, if your calculator does it. But next year, I'm going to make sure that anyone in my advanced class is not allowed to use calculators. Grade 12 is for non-calc until we start doing trig. Yeah, Charlotte, you're true. It's not supposed to be difficult. You're just supposed to know fractional indices. Ollie, did you want to do any of these? Because it's already 22:41. You guys are going to go to bed soon. And so I'm going to go and watch Netflix and think about how you guys are going to do awesome tomorrow on the math test. All right, you want to do E? All right, let's do this one. So that divided by that, so that's x squared minus 2x all over x plus 5. Oops, this is supposed to be a 2x times by, we flip them, 2x plus 10 all over 8 minus 4x. All right, see you later, Ollie. Ollie, I'm doing this one for you, but all right, this one here. Ollie's, he should have sent me an email. It's his fault. Okay, next, let's see. Factor an x out on the top. X plus 5. Maria, do you want me to do anything more? I see you're still listening. You're watching too much Netflix in Portugal, I know it. Now we can write it like this over this. And now this is the negative trick that some of you might remember, where you take a negative outside the bracket. And if you take a negative outside, that switches and that switches. And the good thing about that is whoosh, that goes away. Oh, and we have a 2 down here, don't we? So there's actually a 2 down here. So now we have x over negative 2. Then we're done. Yes, I know Maria's in Switzerland. She's on the chat, I believe. Yeah, everyone was surprised. Very nice, Luna. All right, from the very beginning, watch Charlotte. If you want, all I did was do the keep, switch, flip. So x squared minus 2x all over x plus 5 times by, now these flip, 2x plus 10 over 8 minus 4x. Then I factored everything. X minus 2, x plus 5, 2, I have x plus 5. And this time, Charlotte, if you want, I'll take out a negative 4 from it. And what happens is that becomes negative 2, and I get a positive x. And now I just start crossing things off. That is the same thing as that, except they're just switched, the -2 and the x and -2. Divide by 2. And I have x on top left over. And on the bottom I have -2. Done. Yes, you have to swoop it and factor. First factor, please. So, Ollie, I'm listening. What do you want? No one's allowed to ask any more questions unless I answer Ollie. So Ollie, tell me what you want. Douglas, let me see if I can find something hard for you, Douglas. Hold on. That's so very kind of you, Luna. You get an extra 2 points on your test. No one else does because you're the first one who says that. I see you're looking for a question. All right, here, guys, try this one. It's a good one because there's physics involved. Yeah, no problem, Jeffrey. Take care. Jeffrey, do you have a question for me? Anyone else? This is my last question of the night. You guys better figure out your bearing. Nope. Formulas are on the thing. The formula booklet. It has all the volume, all the area, all the circumference, everything with circles. Quadratic formula. It has y equals mx plus b. It has Pythagoras. It has midpoint formula. It has distance between 2 points formula. It has okay, you guys, I'm going now. Douglas, are you doing this or no? All right, last question. Let's take a look at it. This is one, then after that I'm calling it quits because you guys are delirious. Let's see. All right, let's take a look at it. Runners A and B leave the same point at the same time. So let's draw this point here. That's where A and B are doing. Runner A runs at 10 kilometers an hour due north. So this guy goes this way like that at 10 kilometers per hour. Next, it says runner B runs at 12 kilometers due east. So which way is east? East is this way. So this guy is A, this guy is B, and he runs at 12 kilometers per hour. And because you guys did your physics, you should be able to do this really easily just today. Find the distance and bearing of runner B from A. So now A, so you need to find the distance. So from runner A after 30 minutes. So time is equal to 0.5 hours. And we should know what is it? Velocity is equal to distance over time. That means your distance is equal to velocity times time. So if you want to know the distance that A went, you should go 10 kilometers per hour times your time, which is 0.5. So that means that runner A has gone 5 kilometers. 5 kilometers. And then if you do this again for runner B at 12 kilometers per hour times the time, so if you go V times T or 12 times 0.5, you get 6 kilometers. So runner B goes 6 kilometers this way here. That's 6 there. All right. And then now they want to know, find the distance and bearing of runner B from runner A after 30 minutes. So let's draw. So that guy's at that point, that guy's at that point. Let's draw our north arrow to indicate bearing. So here's my north arrow, okay? Like so. And I need to find this angle here. And I need to find this distance here. So the distance is simple, it's Pythagoras, right? Equals x squared. So x is equal to 25 plus 36. So 46, 56, 61, square root of 61. So someone get out their calculator, give me square root of 61. So please get that out. And now the big question is, how do we find that angle? So if I draw a horizontal line like this and a vertical line like that, we know that this here is 90 degrees here. So you need to find this angle inside here. And we know that this is 6 and this is 5. So now we can use SOHCAHTOA. All right, so 7.81, thank you, 7.81. So we know that they are 7.81 kilometers apart, this x here. And now, if this is my right angle here, we have 6 and 5, and this is my reference angle, isn't it? So what do we have? This is my adjacent, this is my opposite. So we get to use good old tan. You guys love tan. Tan of x is equal to O on A. Yeah, we had something like this in the last test. It was Luna and Charlotte swimming. And now you have to go x is equal to tan minus 1 of 5 divided by 6. So can someone do tan minus 1 of 5 divided by 6 and tell me what you get? Yep, good, Toa. Yeah. So someone give me what, one decimal place, please give me the angle tan minus 1 of 5 over 6. All right. Whoa, that's two different numbers. Who's got their thing on degrees and who's got their thing on radians? It can't be 80.5. That's one crazy angle here. All right, so three different angles. I guess I'm getting my calculator out. All right, mode, degrees, good. You guys put your angle into degrees, please. Or your calculator into degrees. 5 divided by 6, 39.8. So 30, your first one, Douglas, was right. So this is 39.8. And then of course they want the bearing, so you have to figure out from here all the way down to here. So it's actually 90 plus 39.8. And when you add 90, we get 129.8. So there's your bearing, and this was your distance here, 7.81. Good, Douglas. That's right. You're right. So there's how you do this thing, this question, and the IB does like physics questions and math types of things. Okay, so that's that question there. We can check to see the answer. Let's check the answer. So question number 8 on 12D. According to this, 12C, 12, where's a 12D? 7.81 at 130 degrees. Perfect. It's right. So we're good. Good. All right. Guys, go to bed. You'll be fine tomorrow. I'll be in the school really early anyway, so you come find me if you want any more questions done. Cool. You guys have a good night. All right. Thanks, Charlotte, Douglas, Luna, Louis, Kayla, everyone who's tuned in. And I'll see you tomorrow sometime during, in the morning sometime, I'm sure. I'll keep the classroom open. I have one student in until from 9 till 10:30, around 10:30, 11, and then I'll just hang out and wait until Kayla comes in and complains for a little bit. All right. Take care, guys. You guys all have a good night. All right. Ciao, ciao. Sleep well.